Dear students, now we try to start definite integration, which is a new chapter in continuation to indefinite integration. Earlier we have done indefinite integration. Now we try to do definite integration. First of all, we try to see the difference between indefinite integration and definite integration. In indefinite integration, you don't have limits. As you see here, you are having limits. Here you don't see limits. In the question, you don't see limits. In the same fashion, in the answer, we will see constant of integration plus c. In the chapter indefinite integration, we don't have limits in the question, and we will have plus c in the answer. Now we try to start definite integration. By looking into the problem, we can say this problem is related to definite integration as we have limits here. Integral a to b. Integral a to b. You are integrating the function in between the limits a and b. Here, a is called lower limit and b is called upper limit. A is in the below, so lower limit. B is on the above, so upper limit. And A is always less than B. A is less than B. Lower limit is always less than the upper limit. Before going into the definite integration, we try to see the actual meaning here. If we observe this integral 2x dx, the answer is x square plus c. If you observe, you are integrating a function of x. You are integrating a function of x. Treat it as small f of x. Small f of x. Soon after integration, again you will get answer in terms of x. See here. Question is in terms of x. Answer is also in terms of x. Question is denoted with small f of x, whereas answer is denoted with the capital F of x for the sake of our convenience. Which means, if you integrate small f of x, you will get answer as capital F of x plus c. Integral small f of x dx. Question is in terms of x. As a result, answer is also in terms of x. That's what we have to observe in the integration chapter. Whatever be the formula and whatever may be the problem you have done, all the questions are in terms of x and the results are also in terms of x along with c. Along with c. Now, in this chapter called definite integration, we don't have separate formulae. Here we come across important properties. 5 important properties we come across, of which first of all we try to see what is the definition of definite integration. You have to integrate f of x within the limits a to b. As a result, I will get capital F of x with c. Capital F of x plus c. Soon after completion of the integration, you have to apply the limits. Lower limit is a, upper limit is b. Here, if the function is in terms of x, these are the numbers, lower and upper limits are to be substituted in the place of x. First of all, you have to integrate the function. Later, you have to apply the limits. First of all, you have to apply the upper limit in the place of x. If the function is in terms of x, these a and b are also related to x. What the variable we have here, these numbers which are called limits are also related to the same x. In the place of x, you have to replace the upper limit first in the place of x. So, f of b, here you don't have x to replace. So, the same c will get here. F of b plus c minus upper limit minus lower limit. In the place of x, you have to replace a. F of a plus c. Multiply minus inside. F of b plus c minus f of a minus c. Then we can see that c gets cancelled, plus c and minus c. The remaining is f of b minus f of a. This is called definite integration. Indefinite, you don't have plus c. In definite, you don't have c. In the answer, whenever you apply the limits, then c gets cancelled. In the entire chapter of this definite integration, in the answer, you don't have constant, you don't have plus c at the end. You will have only f of b minus f of a, which is a constant. In this entire chapter of definite integration, you will see answer as a constant. You don't see the variable as answer here. Soon after the application of soon after the applying the limits, we will get as a result f of b minus f of a. Let us go into an example how to do problems in this definite integration. Try to understand this example. Integral 2 to 3, lower limit is 2, upper limit is 3, 2x by 1 plus x square dx. What is the formula here? F dash x by f of x. f dash x by f of x. Derivative of the denominator is in the numerator. Derivative of 1 is 0. Derivative of x square is 2x. This is in the form of integral f dash x by f of x dx. What is its formula? Log mod denominator 1 plus x square. So, log 1 plus x square. Here, whenever we do integration, we don't add c here, because if you observe, if you have or if you add c, later on, after applying the limits, anyhow c gets cancelled. అంటే ఇంటిగ్రేషన్ చేసిన తర్వాత c వస్తుంది, అయితే లిమిట్స్ వాడిన తర్వాత c క్యాన్సిల్ అయిపోతుంది. ఎలాగో క్యాన్సిల్ అయిపోతుంది కాబట్టి ఇక మీదట ఇంటిగ్రేషన్ చేసినప్పుడు cని యాడ్ చెయ్యము. ఎందుకు చెయ్యం అంటే చేసిన లిమిట్స్ వాడిన తరువాత కాన్స్టెంట్ ఎలాగో క్యాన్సిల్ అయిపోతుంది కాబట్టి ఇక మీదట కాన్స్టెంట్ని యాడ్ చెయ్యము. కాబట్టి హియర్ ఐ డింట్ యాడ్ కాన్స్టెంట్. Now apply the upper limit first. Log 1 plus, in the place of x you have to replace 3, because these two limits are to be replaced in place of x. These are x limits. So in the place of x you have to replace 3. 3 square 9 plus 1 10. Log mod 10 is log 10. Upper limit is over, minus lower limit. What is the lower limit? In the place of x, you have to replace 2. 2 square 4 plus 1 5. So this is log 5. If you see, this is in the form of log a minus log b. Log a minus log b. So log a by b means 10 by 5. If you cancel, you will get log 2. Log a minus log b means log a by b. It is log 2. Likewise, whatever may be the problem you come across in this chapter, first of all we have to integrate the problem. Later you have to apply the upper limit minus lower limit. As a result, you will get constant. Log 2 is a constant. You don't have x in the answer. So in this chapter, definite integration, in the answer you don't have x or y or z as variables. You will have only constants as the answers. So this is about the definition of definite integration and how to apply the limits.